The 2025 Toyota RAV4 does not have a battery in the engine compartment. If you need to jump start it or charge the existing battery, this is the positive area where you would hook up the cable, and you could hook up the negative to this strut tower bolt here. We're going to show you that now by hooking up the battery maintainer to this vehicle while we perform these services. So this cap is like that. When you take this fuse cover off, you flip the cap up, put on your fender protector. Now you take your positive, that goes here. You take your negative, and that can go there. The challenge is going to be getting a good connection. It might be easier to use the top strut bolt right there. It's a little bit more stable. We know that we have a good connection because our battery maintainer tells us battery voltage. Now we can turn on the flashing sequence at the desired voltage and start it. We can close the hood and get back to what we were doing. Okay, we know our radar cone needs to be at 850.1 millimeters. 0.1 millimeters is very difficult to do, so we're going to stick with 850. We need to be 3,000 millimeters off of the front vehicle line. We're going to get started with what you know we do. We're going to make our 7-step bounding box complete. We are then going to place our radar target and perform a check. Once we are done with that, we will hopefully be able to perform a check with our camera target as well. I'm going to check on GTS right now, see where we're at, so we can get started on this. Remember, our battery maintainer was at 13.8, and here we're at 13.6. So that is the voltage drop from that fuse box to the DLC. Look at that, there's a bunch of raw memory already. Okay, as usual, everything we do starts with the center line, with our plumb bob opposite of wherever our targets are going in most instances. Here is our rear plumb bob set up how we would like it. When it works. Okay, good with that. As usual, we then proceed to making our driver side line. The goal here is to take your 7-step box tool and just lightly push it up against the tire. Once you have that, you want to line it up with the center of the wheel. We're happy with that result. We then confirm that we have a nice straight line through the center of our tire. Moving on to the front, we are going to do the exact same thing. The only difference is we now want to make a perpendicular line that crosses over our rear target, as well as centering the 7-step bracket to the front wheel. Once we have this lined up to the rear and to the wheel, we can now proceed. Our next step here is to make our center line. Let's go look at this setup. I'm really happy with that result. Looking at the rear, you can see it hits the plumb bob dead center. Now we're ready for the passenger side. Same exact concept from the driver's side as we always do. Line it up with the center of the wheel and keep the target flush with the tire. The rear is in place. Let's make our front line. Now our bounding box is complete. Here we are, center wheel. Cutting across the rear. We're ready to make our front vehicle line and drop our target somewhere around here. Okay, good with that. Measure out 3,000. Now I'm ready. Here we have the front vehicle line. Here we have the 7-step bracket that takes the existing bounding box line coming from the front wheel. There we make our front vehicle line starting at the license plate bracket because it's so easy to make that line. We come forward with our tape measure, 3,000 millimeters, and use another 360 bracket to make our line across to the center line. Guess what? Perfect X. And the passenger line. The reason for the passenger line is for the camera system. It also ensures that the radar is pointed directly at the emblem. Now I take my radar and my ruler and I measure out 850 or 850.1, which is, impossible, but we're going within the realm of possibilities here. Now I have that set. I'm just going to back it up to the target just so we can compare the height. It is dead center. Pretty interesting. Sometimes they're not. Sometimes they're up a little bit, down a little bit, but this one is on the money. Now, we simply take our radar and set it where our lasers are indicating it belongs. The beauty of using lasers is that you can really dial in how precise your measurements are. Here, we are cutting across, and we are centered with the target, which should be nice and square with the car using our bounding box. This is what simplicity, speed, and accuracy looks like. Now let's see how we did. This is a brand new vehicle, and that is what the specs look like direct off the showroom floor. We're used to seeing this at about 1.5 degrees. That can vary. So it's interesting to see that it's coming fresh out of the factory just like this. Now with our setup, we're going to use the 7-step math method and determine where the front line for the camera targets is going to go. We're going to set up our camera target, place it at the correct height, and we're going to see if we can do an adjustment check with this vehicle. I'm going to remove the radar cone. We're going to exit out of this, go back to System Select and Front Recognition Camera. We do have a misalignment reading. Very cool. Now, let us do the sequential recognition and see what our math is here. Okay. $20.51 minus 381 equals that. We're going to divide that by 2 and get 835, and then we're going to add 381. So our front measurement is going to be 1216 right here. We are going to take our existing and go over to 1216. Now, the only difference between what we did prior and what we're doing now is I'm also going to measure out the right side because I want my cross line to be a little bit more perfect. Now I'm going to go across to 1216 on this side and mark it out. 1216 would be there. You see, I'm actually slightly off. I need to adjust my angle a little bit. My goal here is just to get us in line right there. Now let's see what our target height or desired height should be. 1350. Okay. That is exactly what we want now. We're going to adjust our target to the proper height. Oh, 550 apart. Those are 750. Those are 550. So it is the lower ones. Being that we are the lower ones, where is our 1350 number? Okay. Minor adjustment. Perfect. Hopefully you can see that. 1350. Our target is nice and level. We're ready to perform the axis check. I want you to set the memory first. Let's review the results. According to the misalignment reading that GTS gives us, the placement of our target is within a 1/4 degree of where it should be mathematically everywhere except for horizontally. So this goes to show you how accurate 7-step box is when you're using it to perform ADAS calibrations and placing targets exactly where they should be the first time without consequence. We can probably piece together the time that this took from the computer screen because it'll have a start time and it'll have the time right now. The time really isn't like what we're bragging about here. Accuracy is. This target was almost exactly where it should have been according to manufacturer spec based on the mathematical calculations they have you input into the camera. Our system works. Not only does it work, it's incredibly quick, repeatable, and it actually teaches your technicians how to think, what to do, why to do, and when to do it. Thank you for watching. We're now going to work on turning this vehicle around and doing a blind spot calibration to see how we pan out there. I'm going to move everything out of the way now. In doing so, I'm going to have to reset all of these lasers and remeasure again. And you're going to see how much time that takes, also based on the computer. This is not difficult. This just requires you to be interested in what you're doing, reading, and actively being involved in the process. Once you understand how to identify sensors, how to read OE information, everything else becomes really, really easy, and we're here to teach it to you.